So, good morning. In the last class, we were discussing about the concept of latitude. We covered longitude. We also covered the different countries that are cut through latitude, different latitude like equator, Tropic of Cancer, Tropic of Capricorn. So, we also discussed Indian Standard Meridian, how times you can calculate. Those things we have discussed in the last class. So, which are the Indian states which are cut through Tropic of Cancer? Indian state which are being cut through Tropic of Cancer.
Indian states.
Hmm.
Gujarat,
Huh.
Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram.
Is Rajasthan state being cut or not being cut?
No, sir.
No. Fine. So those are okay. What? Those are states that are being cut. Then we also discussed the important countries which are cut through Arctic Circle. What are the important countries which are cut through Arctic Circle?
Canada, USA, Norway, Sweden,
Sweden, Finland, Russia,
Greenland.
Iceland and Greenland. Greenland is a part of Denmark. Fine. So those part we have covered in the last class. And we were discussing about rotation revolution. We talked about equinoxes. When equinoxes occur? When these equinoxes occur?
23rd of September.
Yes, 23rd of September and 21st of March. 21st of March and 23rd of September. So you see spring equinox and autumn equinox. Fine. When you see the summer solstice, when you see summer solstice, when you see winter solstice, 21st June is summer solstice and
2nd December is winter.
Fine. So those things we have discussed: summer solstice and winter solstice. Fine. Then we discussed the concept of temperature or solar insolation. We covered insolation and we also covered concept of albedo. So that is what the discussion ended. The insolation and albedo. What is insolation?
Proportion of light intercepting by.
Yeah, the proportion of sunlight that is being intercepted by the earth is called as what? Is called as a solar insolation. And what is albedo? Yeah, the amount of solar insolation that is reflected by Earth's surface is called as what? Is called as a albedo. And we discussed another aspect, which is that solar insolation that is received by Earth is not constant. It is varying. Why it is varying? What are the reasons? The one reason is distance. Earth distance is changing. Then second reason. We discuss solar constant or sunspot. We discuss sometimes sunspot are being appearing. Sunspot are what? Dark spot. Because of whenever sunspot appears, what will happen? The sun will emit lesser radiation. Whenever sunspot are not there, sun is going to emit what? More radiation. So sunspot we have discussed. The third thing that we have discussed is what? The third thing that we discuss is altitude of the sun. So if sun is vertical, then what will happen? If sun is vertical, then what will happen? We discuss lesser chances of reflection and refraction. If the sun's rays are coming in slanting manner, then what will happen? More chances of reflection and refraction. So we discussed the solar insolation. Solar insolation is impacted due to what? Is impacted due to the altitude of sun, sunspot, as well as distance of Earth from sun. Distance of Earth from sun. These are the reasons why solar insolation is not uniform and solar insolation keeps on varying. Fine. Then we are coming to what? We are coming to the concept of factors affecting temperature distribution. What are the factors that are impacting the temperature distribution on Earth's surface? that we are now going to cover. Factors affecting temperature distributions. Fine. Remember, as we discussed, there are three sources of what? Three sources of heat transmission. What are the three sources? Conduction, convection, and radiations. So we discuss heat transfer happens in these forms. Radiation means what? No medium is required. Convection means happens in fluid. Fluid means what? Fluid means what? Liquid and gas. And conduction happens in which medium? Solid medium. So we discuss primarily the heat transfers happens in this form. Sun's solar energy is coming in form. Solar is coming in radiation form. No medium is required for sun's energy to reach to the earth. So that's why solar radiation. It is called as a solar radiations. Fine. So what are the factors which are affecting the temperature distribution on Earth's surface? As we discussed in the last class, we have three zones. This is equator. We have Tropic of Cancer and Tropic of Capricorn. Then we discuss what? We have Antarctic Circle. And we also have what? Arctic Circle. So we discuss these are important latitudinal aspect of Earth. So you see this region between Tropic of Cancer to Tropic of Capricorn, we call it as which zone? Torrid zone. Yes. Between this region, we call it as which zone? Temperate zone. And beyond this region, we have which zone? Frigid zone. Fine. So this part we have discussed. So why do you see there is a difference in temperature at different part of Earth? Why this temperature difference is something that is varying? Why do you encounter three different zones? Torrid zone, temperate zone, frigid zone. Why you are encountering these zones? Why there is a variation in temperature distribution? Some regions are very hot, some regions are very cold, some regions are something that is neither hot nor cold. Moderate temperatures are something that are there. So there are various factors responsible for what? Varying temperature on the Earth's surface, and this is what we call as the factors affecting temperature distributions. Fine. So why these variations are there? Why some regions are very hot, some regions are very cold, or why some regions are moderately hot or moderately cold? This is because of certain factors, and that's what we are going to study, factors affecting temperature distributions. Fine. So the first factor which is affecting is called as angle of inclination. Angle of inclination of solar radiations. At what angle the solar radiations is coming, this angle of inclination of solar radiation is one of the factors. Fine. So last class we discussed, if sun's radiations are coming in what? In vertical manner, then what will happen? More energy will be received. If sun's radiations are coming in which manner? Slanting manner, less energy is being received by the earth. Less energy is being received by the earth. So here angle of inclination is 0 degree. Here angle of inclination have higher degree. So when it is coming in slanting manner, less energy is going to be received by the earth. When it is coming in vertical manner, what will happen? More energy is being received by the earth. So where you see it is coming in vertical manner, where it is coming in vertical manner, as we discussed, sun's position varies between Tropic of Cancer and Tropic of Capricorn. So sun is directly giving energy on these regions, but as compared to polar region, where it is going in which manner? The radiation is going in slanting manner. So that's why polar regions are receiving nothing but lesser amount of sunlight. Fine. So angle of inclination is one of the factors that is determining whether temperature will be more on the Earth's surface or whether temperature will be less on the Earth's surface. Fine. So as we discussed, if rays are coming in slanting manner, there is more chances of what? Reflection, refraction, But when it is coming in what vertical manner, there is a less chances of reflection and reflection and refraction. Fine. So this angle of inclination of solar radiation is one of the factors. The second important factor that you find is duration of sunshine. Duration of sunshine. Now, as we discussed, if daytime is more, then what will happen? If daytime is more, what will happen? You will receive more sunlight, more radiation, more energy. Energy will be more. If night time is more, then what will happen? Then you will radiate more energy. Then Earth will radiate energy. Earth will radiate energy, and as a result, Earth cools down. Earth cools down. Here, Earth will become hot. Earth will become hot. So daytime, what is happening? If daytime is more, then what will happen? You will receive more amount of sunlight. More amount of sunlight means more energy. More energy means Earth will become hot in nature. If night time is more, then what will happen? Earth will radiate energy. If Earth will radiate energy, what will happen? It loses energy. Loses energy means what? It will cools down. Fine. So if more duration of sunshine is there, then what will happen? More energy are going to be received. If less duration of sunshine are there, then what will happen? Less energy are being received. So that's why you see poles have what? Poles have a 6 month of night. When they have a 6 month of night, then what will happen? What will happen? They'll cool down. While we discussed equator region receives more amount of sunlight. That's why it is going to be which region? It is going to be hotter region. So duration of sunshine also plays an important role in case of temperature distributions. Fine. The third factor that you see is okay, transparency of atmosphere. Transparency of atmosphere. This factor also determines how much temperature or energy is going to be received by the Earth. Transparency of atmosphere. You know that this is a Earth surface. This is okay, your atmosphere. Atmosphere contains many amount of what? Many amount of particle. These particle can be bigger particle. This particle can be smaller particle, very small particles also. So you have atmosphere consisting of many particles. We have discussed what? We have discussed atmosphere consists of gases. Atmosphere consists of aerosol also. What is aerosol? What is aerosol? The suspended particle. Which are the suspended particle? Either solid particle or liquid particle. If suspended particle, solid particle or liquid particle, then it is called as what? Clear? Yes. So what you see is okay, the sun's radiation is coming. Clear? The sun's radiation is coming. If sun's radiation wavelength is more than radius of obstructing particle. Radius of obstructing particle. Clear? So if radiation wavelength, sun's radiation wavelength is greater than radius of obstructing particle, in that situation scattering will take place. Which phenomena will take place? Scattering will take place. If wavelengths, sun's radiation wavelength is greater than radius of obstructing particle, then what will happen? Scattering phenomena will take place. Clear? Now the second situation is, if radiation wavelength, sun's radiation wavelength which is reaching to the Earth's surface is equals to radius of obstructing particles, then what will happen? Then absorption will take place. absorption will take place. And the third that you see is, if radiation wavelength is equals to, or sorry, less than radius of obstructing particles, then what will happen? Then reflection will take place. So these are the scenarios that you can have. If atmosphere is having lot of what? Atmosphere is having lot of gases, aerosol particles. So they impact what? They impact the radiation. Which is reaching to the Earth's surface. So as we discussed, if the radiation which is coming, is encountering particles which is very small, then what will happen? Scattering phenomena takes place. Scattering means what? Light will be scattered in different directions. Clear? Now if radiation encounters obstructing particles which is equal, then what will happen? Absorption will take place. And if they encounter a particle whose radius is bigger than this one, then what will happen? Reflection will take place. So these phenomena is something that is taking place in the case of atmosphere. Fine. So either absorption or scattering or reflections. Fine. Next factor that can affect the temperature distribution on Earth's surface. Done. So next factor that can affect temperature distribution on Earth's surface is prevailing wind. That you know that wind will blow, and wind will blow from one area to another area. We discussed generally wind blows from which area to which area? High pressure to low pressure. We discussed wind generally blow from where to where? From high pressure region to low pressure region. Where low pressure regions are being formed? We discussed generally where hot conditions are there, because you know that anything heated will expand. Expansion will happen because of low pressure. Anything that you try to contract will be contracting because of what? High pressure. So high pressure is formed due to what? Due to cold condition, and the low pressure is going to be formed due to hot condition. So when wind is blowing from high pressure to low pressure, what will happen? Wind will take some of the colder condition from where to where? Cold wind is going to come. When cold wind is going to come from here to here, what will happen to hot condition? This hot condition temperature here will come down. Why temperature here will come down? Because colder wind are coming. Because of colder wind coming, temperature will come down. So even wind, whenever wind blows, wind also helps in temperature distribution. Clear? They takes the colder wind from one region to another region, and as a result reduces temperature on one side. Fine. Then we discuss another factor which can cause different distribution of temperature is land-sea differentiation. Land-sea differentiation. What is land-sea differentiation means? We discussed, remember the concept of specific heat. What is specific heat? We discuss, amount of energy required to raise a temperature of a body by 1 degree Celsius. This is called as a specific heat. Amount of energy required to raise a temperature of a body by 1 degree Celsius. So we discussed land has what? Land has a lesser specific heat. So it lesser specific heat, that's why it get quickly heated also, and quickly cools down. Less energy is required to heat it, and that's why it cools down quickly also. While water takes time, water has more specific heat. As a result, water takes times to get heated. And it also takes times to cool down. Fine. So this phenomena you observe, and this is called as a land-sea differentiation. Clear? So when the sunlight comes, what will happen? We discussed land part is going to get heated more, while the sea remains cooler. Why sea remains cooler? Because it takes times to heat. So that's why sea remain cooler. That is okay there. Clear? As a result, here what will happen? Low pressure formation happen. Here what will happen? High pressure formation will happen. Clear? So as we discussed, whenever anything is getting heated, what is formed? Low pressure. Whenever anything remains cool, what is formed? High pressure is being formed. So again, wind will flow from here to here. So this land sea differentiation is also causing different heating. Here temperature will be higher, here temperature will be lower. This is happening due to land sea differentiation. And why land sea differentiation is happening? Due to different specific heat capacity. In fact, the specific heat of water is around 2.5 times greater than what? Greater than the specific heat of land. So specific heat of water is around 2.5 times greater than the specific heat of land. So if you are providing 1 joule of energy to heat land, and it is raising the temperature by 1 degree Celsius, you have to provide how much energy? 2.5 joule of energy to raise the temperature of water by 1 degree Celsius. So if 1 degree Celsius temperature increase is happening in land by 1 joule of energy, the similar 1 degree Celsius rise in water will happen if you provide more energy. That is okay there. So that's why specific heat of water is almost 2.5 times greater than the specific heat of land. This causes differentiation, what we call as a land sea differentiation. Fine. So this is okay. Another factor which is okay, which is causing the difference in distribution of temperature on earth. Clear? Next that you find is aspect of slopes. This is also impacting temperature distribution on earth. Aspect of slope is also impacting temperature distribution on earth. Fine. What is aspect of slope means? Let's say this is a mountain. Now if sun is coming like this, solar radiation is coming like this, then which part of the mountain, which slopes of the mountain will get heated? This part, because this is getting what? This is getting the sunlight, so this part of the mountain will what? Get heated. This slope of the mountain will get heated, while this slope of the mountain is not getting what? This is not getting the sunlight. When this is not getting the sunlight, what will happen? It will remains cooler. So this part will become cooler, while this part will become what? Warmer in nature. This part will become cooler and this part will become warmer in nature. Clear? Because sunlight is being received by one of the slope, it is not being received by one of the slope. So that's why this part will remain warmer, this part will remain cooler. That is okay there. Clear? That's why warmer means what? Here more evaporation will take place. You can see more population can reside over here. You can find more population on this slope of the mountain. You can see more evaporation. Here you'll see less evaporation because less sunlight, so less evaporation. You'll also find less population. because sunlight is not coming. So here you will find less population, and that's why more forest. This region can be more forested, more humans, less humans, more forest can be seen on the other side of the slope. Fine. So this is how we see aspect of slope is what aspect of slope is determining which side will get more heat, which side will get lesser heat, and etc. That is okay there. Clear? So remember we discussed this is okay what this is India, and this is where Himalayas are having. This is where Himalayas you are finding, and we discussed Tropic of Cancer is fine. Okay, going like this. Tropic of Cancer is something that is going like this from the middle part of India. Now, if the sun is overhead at Tropic of Cancer, which slopes will receive more sunlight? Which slope? Only southern slope, because southern slope is getting the sunlight. Northern slope will not get what? Northern slope will not get the sunlight because northern slope is away from the sunlight. Southern slope of Himalayas will receive sunlight. Northern slope of Himalayas will not receive sunlight. That is okay there. Clear? That's why northern slope, Tibetan region, you'll see more okay what? More nothing but okay colder region, more colder region. Why? Because not receiving much of sunlight, while southern slope is receiving more amount of sunlight. So more okay what? More population you are seeing, or more people you are seeing in the southern region. So even the way mountains are there, which part of the mountain is receiving sunlight, can also determine whether you will have more temperature or whether you have less temperature. Fine. Then you also have another factor, which is oceanic current. You will have another factor, which is oceanic current, that also can determine that whether the temperature, whether the region will receive more amount of sunlight or whether region will receive lesser amount of sunlight. So you also have something called oceanic current. Fine. So what is this oceanic current? As we discussed earlier, that if oceanic currents are coming from where? If oceanic currents are coming from where? From the polar region, then they are going to be what? Colder in nature. If they are coming from equator region, then these current are going to be what? Warmer in nature or hotter in nature. That is okay there. Clear? So if current is developing from the equatorial region, then what will happen? It will bring warm current. If the current is developed from nothing but okay polar region, then what will happen? It will have a colder current. So colder current will bring what? Which type of water? Colder water. When colder water is there, then what will happen? What will happen to air here? If water is cold, then what will happen to air? It also becomes cold. If air becomes cold, what will happen? Air will not expand. When it will not expand, what will happen? You don't see rainfall. So that's why we discuss deserted conditions. We discuss deserted conditions are found on the western side. Clear? On the other side, if water is hotter in air, then what will happen? Air will also get heated. When air get heated, air will expand. When air will expand, what will happen? Condensation, cooling will happen, rainfall will happen. So that's why you see even oceanic current can determine which part will have more amount of temperature, which part will have lesser amount of temperature, which part will receive more rainfall, which part will receive lesser rainfall. This also are dependent on oceanic current. Fine. Fine. Next is what? Next is altitude. So another important factor is that is determining the heat distribution is going to be what? Is going to be altitude. How altitude is something that is okay determining. So as we discussed, if sun is what? We discussed sun radiations are coming. It is heating the earth. When it is heating the earth, what is happening? Earth is radiating which energy? Earth is radiating which energy? Terrestrial radiations. It is emitting which radiation? Terrestrial radiations. Fine. Fine. So you'll see what? You'll see altitude is also one of the reason why you see difference in temperature. So we discussed sun's radiations are come, sun's radiation are heating the earth. As a result, earth is emitting which radiation? Terrestrial radiations. So as we discussed, if you are okay, what if you are here closer to the earth's surface, warmer conditions are going to be there. As you are going above, what will happen? Temperature will decline. Why temperature will decline? Because you are moving away from what? You are moving away from the earth. What is the source of radiation? Source of heat? Source of heat is earth. Clear? So that's why in the mountain region you see colder temperature. In the planar region you see nothing but okay, warmer temperature. So this is happening because of what? This is happening because of altitude. This is happening because of altitude. As you are moving away from the earth, you'll see variation in what? Variation in temperatures. Finally, you also have variation in temperature due to what? Due to solar insolation. Due to solar insolation, you'll also have variation in temperature. So last class we discussed solar insolation. If more energy is intercepted by the earth, more energy intercepted by the earth, what will happen? What will happen? More energy intercepted by the earth, what will happen? You'll see what? You'll see earth will get more heat. If less energy is intercepted by the earth, what will happen? Earth will receive what? Earth will receive lesser heat. Fine. So more energy intercepted by the earth, you'll see earth will be having more heat. Less energy intercepted by the earth, then you'll see it is having lesser heat. Fine. Fine. So this part you have to keep in mind with regard to solar insolation. And last class we discussed why solar insolation will vary. Why solar insolation will vary? Three factors just now we discussed. Because distance of earth and sun are not constant. It is keeps on changing because of revolution. Second we discussed is what? Sunspot cycle. And of course we discussed the rather we have written angle of inclination of sun. That point we have already written. So angle of inclination of sun, at what way sun's rays are coming, whether it is coming in direct manner or in slanting manner, so that will vary the solar insolations. Fine. So even this will affect the what? This will affect the temperature distributions. Fine.
So, can you go to the slide? The third one.
Third. Fine. This is transparency of atmosphere.
The other one is absorption.
And the third is reflection. Fine. So these are the factors that are affecting what? That are affecting the temperature distribution on Earth. And that's why you see some part of the Earth having more temperature and some part of Earth having lesser temperature. And that's why we classified them into torrid zone, temperate zone, and a frigid zone. Fine. Now there is a term also which is called as a isotherm. Isotherm.
Different topics.
No, part of this only, but the term we are dealing with the term. So therm means what? Therm means temperature. It is dealing with what? Temperature. It is a, remember we talked about something called isosysmic line. We talked about this line. What was isoseismic line? Yeah, the line joining the places with same intensity of earthquake, that is called as a isoseismic line. So that the similar term is isotherm. So line joining places with equal temperature is called as what? Is called as a isotherm. So isotherms are imaginary line. These are imaginary line drawn on a map, joining places with equal temperature. So it is an imaginary line drawn on a map joining places with equal temperature. Fine. So let's say this is the map. Let's say temperature here is 28 degrees Celsius. 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 So when you connect the line like this, this is going to be called as what? This is going to be called as a isotherms. This is going to be called as a isotherms. So it is line joining places with what? Places with equal temperature. Now there are certain characteristics of isotherms. There are certain characteristics of isotherm that you have to keep in mind. First is isotherms generally follows parallels. Generally follows parallel. What is generally follows parallel means? Parallel means what? We are talking about latitude. Remember, parallel latitude and meridian what? Longitude. So isotherms generally follows parallel. Fine. So as we discussed, latitude like this, 0 degree, 1 degree, 2 degree, 3 degree. As you go up, 90 degree latitude. As you go from here to here, what will happen to temperature? Decreases. From equator region to the polar region, what will happen? Temperature will nothing but decrease. Clear? So as a result, if you connect the places with equal temperature, you will generally see a line going parallel to what? Line going parallel to the latitude. So that's why it says isotherm generally follows what? Generally follows the parallel part. Fine. Any doubt? The second thing, it says, a characteristic says there will be sudden bending observed in isotherm. Sudden bending observed in isotherm, generally at ocean continent boundary. There's a sudden bending observed in isotherm, generally at which boundary? At ocean continent boundary. Fine. Fine. So why there is a sudden bending being observed? Let's say this place is having how much temperature? 28 degrees Celsius. This place is having how much temperature? 28 degrees Celsius. Now I'm talking about this latitude. I'm just making this with this. I'm talking about this latitude. This latitude. Okay, so at the land, this temperature is how much? At the land, the temperature is around 28 degrees Celsius. But what will happen to the sea? What will happen to the sea? We discussed sea, land, sea differentiation just now we discussed. So if, okay, what will happen? Land is getting more heated, sea will not be getting that much heated. Clear? So generally sea will have how much temperature over here? Lesser than the land temperature. So if land is having around 28 degrees Celsius, maybe sea will be having how much temperature? 24 degrees Celsius, that is okay there. It will have 24 degrees Celsius at the same latitude. So when the sea will have, okay, 28 degrees Celsius temperature, where the sea will have 28 degrees Celsius temperature. So you know that this is equator. So closer to the equator, if you go, what will happen? Temperature will increase because more sunlight are going to be there. So let's say at this point, sea will have, okay, what? Sea will have nothing but, okay, 28 degrees Celsius temperature. So now you connect the places with equal temperature, what will happen? We'll see like this. So what is happening? Bending are being observed at, okay, what? Ocean continent boundary. Bending are being observed at a ocean continent boundary. So that is okay. Second characteristic of isotherms. So what you see is, okay, isotherms are generally following what? Generally following the latitude. But at the, okay, what? At the ocean continent boundary, you see bending will be observed. Fine. The third characteristic, it says that if isotherms are closer means narrow spacing, or isotherm having wide spacing. So if isotherms are narrow spacing, what does it mean? It means there will be what? There will be sudden variation in temperature, or rather you write down quick variation in temperature. There will be quick variation in temperature. Clear? If isotherms are wide spacing, then there will be slow variation in temperature. There's slow variation in temperature. So isotherms narrow spacing, what does narrow spacing means? Sudden or quick variation in temperature. Isotherm wide spacing means what? Slow variation in temperature. Fine. What does it mean? Let's say this is okay, what? This is okay, the region. I'm saying this is okay, what? This is okay, all the places I'm connecting with the isotherm. This is a line that I'm connecting. All places are how many degrees Celsius? 28 degrees Celsius. Let's say now next line I am drawing over here. These line indicate places with 27 degrees Celsius. This line indicate places with which degree Celsius? 26 degrees Celsius. So if isotherms are wide spacing, if they are wide spacing, that indicate there is a slow variation in temperature, slow decline in temperature. But if isotherms are like this, they are like this, then what will happen? Then it indicate quick variation in temperature. Clear? So there will be 28 degree isotherm, 27, 26, 25. So within this range only, you see the temperature decline from 28 to 25. You can see here temperature is declining this much only in what? Only 2 degrees Celsius decline in temperature is something that is okay happening. Clear? So if isotherms are widely placed, what does it indicate? It indicates slow variation in temperature. If isotherms are narrow drawing are there, then what will happen? It indicates quick variation in temperature. Clear? So this is what characteristic of whom? This is what characteristic of isotherms. So isotherms generally follows what? Generally follows the latitude, they generally follows the parallel. As you go away from equator to the poles region, what will happen? Temperature will decline. The second important thing, sudden bendings are being observed where? Sudden bendings are being observed in ocean continent boundaries. The sudden bending are being observed. The third is isotherm is what? Isotherm is narrow spacing and wide spacing. Narrow spacing indicate what? Sudden variation in temperature. Wide spacing indicate what? Slow variation in temperature. Fine. Now, let's say now we are talking about northern hemisphere. We are talking about northern hemisphere over here. Northern hemisphere means this is equator. This is equator. Fine. So this is what? Okay, the map you are getting. This is okay, what? This is Africa. This is Arabian region, Iran, Pakistan, India, that part, okay, you are finding. Now, we are talking now with regard to which condition? We are talking with regard to northern hemisphere summer condition. In northern hemisphere, when there is a summer condition, or the second that we talked about is northern hemisphere, when you will have winter conditions. So two conditions we are talking about. One is okay, summer condition. Second condition we are talking about is a winter conditions. Clear? Let's say summer condition means what? Summer condition, what does it indicate? So you know that this is Tropic of Cancer. You know that in summer condition, when summer occurs, summer solstice is when? When is summer solstice? 21st of June. Assume there is a 21st of June, so sun will be where? Sun will be at Tropic of Cancer. You know that equinoxes, sun will be at equator. Winter solstice, sun will be where? Sun will be at Tropic of Capricorn. Fine. So we are assuming that sun is over here. When sun is over here, which land is going to be what? Land is going to be heated more. So if sun is over here, what will happen? Land is going to be heated more. Okay. So land is going to be what? Land is going to be heated more in such situation, which you are finding with regard to what? With regard to the Tropic of Cancer region. Clear? So let's say this part will have temperature. I'm taking this part as a temperature, this part as a temperature, this part as a temperature. These are the points I'm taking on the map. Fine. These are the land points. Let's say temperature here is what? Temperature here is somewhere around 30 degrees Celsius. How much is the temperature? 30 degrees Celsius. Fine. Correspondingly, at the ocean, where the 30 degrees Celsius is temperature, so if I'm connecting this line, you see this is how I'm connecting this line. All joining which temperature? All joining places with 30 degrees Celsius temperature. Fine. So all these are 30 degrees Celsius temperature. This is 30 degrees Celsius temperature. Correspondingly, at the oceans, where do you find 30 degrees Celsius? Near the equator. Yes. Okay. So as we discussed, at this point, the oceans will have what? Oceans will have somewhere around 25 degrees Celsius. They will be having lesser temperature than the land, because water get times to heat and water get times to cools down. So water will have somewhere 30 degree around over here. 30 degrees Celsius closer to the equator. That is okay there. Clear? So if I have to connect isotherm, then isotherm will be like this. Isotherm will be connected like this. So this is how you see 30 degree isotherms are something that are there. Clear? So isotherms are connected like this, because here at the land 30 degrees Celsius is going to be there, and here what you see is okay. You'll see this particular line that at the ocean 30 degree will be closer to the equator. As you move away from the equator, temperature will nothing but okay decline to 25 degrees Celsius. So this is how isotherms are being placed in the northern hemisphere in the summer condition. So we say isotherms are shifted southward or equatorward. So this is okay, what? Equator. This is south side or equator side. So isotherms has shifted towards where? At the south side or equatorward at the oceans and northward or poleward at the continent. So this is how you are seeing the position of isotherms. Clear? So isotherms are shifted towards south or towards equator, where at the oceans they are shifting south, at the continent they are shifting what? North. So they are shifting northward or towards pole at the what? At the continent. This what you are getting from isotherm, which is in northern hemisphere. Fine. Any doubt regarding this particular part? Now the same thing we are talking about now, the winter condition. What will happen in winter condition now?
This is only for summer condition.
This is only for summer condition. This is okay for summer condition. Now what will happen in winter condition? So as we discussed, winter conditions, sun position will now shift towards where? Tropic of Capricorn. So earlier summer condition, the sun was at which position? Tropic of Cancer position. At winter condition, sun shift towards where? Sun will shift towards Tropic of Capricorn. So sun position will shift over here. Clear? When sun position will shift over here, what will happen? Now you see the northern hemisphere will get lesser sunlight, because okay, now the sunlight is going in slanting manner. Okay, it will receive lesser sunlight. So when lesser sunlight, what will happen? Winter, what will happen? Long night, what will happen? When long night will be there, what will happen? Land will lose energy, while water will take times to what? Cools down. Clear? We discussed land quickly get heated and quickly cools down, while water takes times to heat and water takes times to nothing but okay cools down. So here land we are talking about this point now. This is a land. I'm taking now this part land. I'm taking this part of land. Clear? So let's assume that here 10 degrees Celsius temperature are there. We are talking about this. How much degrees Celsius temperature are there? 10 degrees Celsius temperature are over here. Correspondingly, what will be the water temperature over here? More than that, because water takes times to cool down. So water will have, let's say, around 15 degrees Celsius temperature. Water will have how much temperature over here? 15 degrees Celsius temperature over here. Land quickly cools down, so land will have lesser temperature. Water will have more temperature. So where the water will have 10 degrees Celsius? Where the water will have 10 degrees Celsius? If you move away from the equator, because as you move away from the equator, what will happen? Temperature will decline. So water will have 10 degrees Celsius somewhere over here. So this will where the water will have 10 degrees Celsius. So now if I connect the isotherms, how you'll find? You'll find this is how isotherms are something that are there at the at the winter condition. So what you are finding now? What conditions you are getting with regard to isotherm in winter? So isotherms are shifted northward or poleward over oceans and shifted to southward or equatorward towards continent. So this is how you see variation of isotherms. Fine. So in summer, isotherms are shifted southward or equatorward at the ocean, but in winter, their isotherms are shifted southward or equatorward towards continent. So this is continent. You are seeing it is southward or equatorward. This is okay. What? This is nothing but okay northward condition that you are seeing poleward condition. So this is how you see placing of what? Placing of nothing but okay isotherm in summer conditions and in winter conditions. Fine. Clear? So keep these 2 points in mind, where the summer condition where isotherm will be placed, in winter condition where isotherm will be placed, where in the northern hemisphere. Fine. Fine. Now the same thing if you see with regard to southern hemisphere. Now we are talking about southern hemisphere, and this is again we are taking at what? This is equator. This is your tropic of Capricorn, and this is nothing but okay tropic of Cancer. Fine. So this is how you're finding so this part is which part? Australia part. Well, this part is which part? African part. Fine. So we write down this is equator. This is tropic of Cancer. Tropic of Capricorn. Fine. Again, the same condition we are taking summer condition and winter condition. Winter conditions. Fine. So first we are taking up which conditions? First we are going to take up summer condition in the southern hemisphere. So what will happen in summer condition? Let's say summer means what? Where the sun position will be there. Sun position will be at Tropic of Capricorn. Summer means what? When the southern hemisphere will face a summer, when sun position will be at Tropic of Capricorn. Fine. Now, when sun position is here, let's say this particular line we are taking, this isotherm we are taking, here let's assume 33 degrees Celsius is temperature. Correspondingly, you also assume here lies your 33 degrees Celsius temperature. But we discuss what will happen at the oceans. The same latitude, what will happen to the oceans? Ocean will be much cooler because land get heated quickly, water takes times to. So let's say the oceans has around 26 degrees Celsius of temperature. So where the oceans will have 33 degrees Celsius? Near to the equator. So here, okay, oceans will have how much temperature? 33 degrees Celsius temperature. So when you join isotherms, you'll find points like this. So this is how, okay, you are finding the isotherms. So this is how you are finding the isotherms. So this is going to be what? 33 degrees Celsius. Fine. So how you are seeing variation? So in summer, you see the isotherm shifted northward or equatorward. So this is northward or near the equatorward in oceans, and southward or poleward at the continent. So this is a condition you are getting in the summer. Summer isotherms are shifted northward or equatorward. So it is shifting towards northward or towards equator in the oceans, and towards southward or towards poleward at where? At the continent. Fine. So this is condition you are getting in the summer. In winter, we discuss sun position will shift where now? In winter, sun position now shifted over here. Now when the sun position shifted over here, assume now we are taking this isotherm. Assume here, okay, 10 degrees Celsius temperature are there. 10 degrees Celsius temperature are there. So correspondingly, what will be the temperature at the oceans? At the same latitude, oceans will be what? Oceans will be having higher temperature. Why? Because in winter, we discussed, oceans will take times to cool down. So as a result, let's say here 15 degrees Celsius is there. 15 degrees Celsius is there. So where you'll find 10 degrees Celsius? Where you'll find 10 degrees Celsius? When you come further below, that is okay there. So there you'll find nothing but okay what? There you'll find nothing but okay 10 degrees Celsius temperature. So you'll find like this. Isotherm like this. So you'll find isotherm like this. Fine. So this is how you'll find isotherms. So in winter, what is happening? In winter, isotherms are southward or poleward over oceans, and they are northward or equatorward towards on the continent. So at the continent, you'll see north side. At the oceans, you are seeing south side. This is equator world. This is nothing but okay pole world. So this is conditions you are getting with regard to isotherms. Fine. Any doubt regarding this one? So we discussed why there is a variation in temperature on the, yes. Fine. So we discussed why there is a variation on temperature on the Earth's surface. Variation on temperature is because of lot of reason. As we discussed, there is okay what angle of inclination of suns. There will be wind, how wind is blowing. We discussed how okay what how the mountains, which part of the mountains is receiving the sunlight. What is the altitude? We discussed also the whether the atmosphere is transparent or not. Whether more amount of what, whether more amount of the the refraction is happening or more amount of okay, scattering is happening. So that will decide whether okay which part of earth will receive more temperature and which part of earth will receive lesser temperature. And isotherms are what? Isotherms are the imaginary line. What are the imaginary line? It is an imaginary line drawing connecting the places with what? Connecting places with equal temperature. And isotherms, as we discussed, is going to what? It is going to vary. Isotherms, as we discussed, is going to vary on the northern hemisphere and the southern hemisphere during summer or during winter conditions. Okay, so this part you have to keep in mind with regard to isotherms. Fine. Yeah, tell me.
Now India
Hmm. Hmm.
Kolkata is the right side.
Hmm.
When moving from Gujarat to Kolkata,
Hmm.
Kolkata is ahead of.
Hmm.
When moving to Gujarat to Kolkata,
Hmm.
he is going to ahead, but then he will lose the day, and he will connect to that day also.
He'll lose the day and connect to
On that day,
how much is the difference?
difference is 2 hours.
2 hours, not 2 hours, because 2 hours is difference between Arunachal and Gujarat. Let's say around 1 hour 30 minutes difference between Kolkata and Gujarat. Then
Like
if you are moving from Gujarat, let's say from Surat to Kolkata, if you are moving, what will happen?
he will lose the day.
No, day will lose.
Far away from the 2 hours something. They are far away from.
No, they are not far away. They are far ahead.
Far
Yeah.
away. So when we go there, we will lose this time and we will adjust to that time.
Yeah.
Then we will lose this. What is the traveling?
See, what is happening is when you are moving from one part of the India to another part of India, the meridian is changing. When meridian is changing, what will happen? Time will change. But we discussed we are not taking the meridian time. We are taking which time? IST, Indian Standard Time, so that we don't have to adjust clock whenever we are moving from one areas to another areas. We don't have to adjust clock. We are taking only one time, which time? Indian Standard Time. And what is Indian Standard Meridian? 82.5 degree. Fine. Now, when you are moving from Surat to Gujarat, let's say forget about IST now. When you are moving from Surat to Kolkata, when you are moving, let's say Kolkata is 1 hour 30 minutes ahead of Kolkata is 1 hour 30 minutes ahead of Surat, Gujarat. Fine. Now, if the person is moving from here to here, he is not going to lose a day. He is going to lose what? He is going to lose hours. Okay. So let's say he is moving from what? He is moving at 10:30 from Surat, that is in Gujarat, to Kolkata, which is what, which will, let's say here it is happening 12 p.m. because it is 1 hour 30 minutes ahead of 1 hour 30 minutes ahead of nothing but this one. So here time is Kolkata. Now, so when he is moving from here to here, what time he is losing is what? 1 hour 30 minutes. That time he is losing. He is not losing a day. Clear? He is not losing a day. He is losing the time. Fine. This is
compared to the countries also. Then if you from Africa to Australia, he will lose a day also. Right?
Africa to Australia, he'll not lose a day. Again, he'll lose a time.
But yesterday,
It ideal loses 1 day.
Which one?
Ideal.
Ideal. Across ideal, you lose 1 day.
so but yesterday moving across west to east, ideal is like the person gains a day.
So that is across ideal, no? 180 degree. When you are moving on 180 degree longitude from west to east, what will happen? You lose a day. But on Australia, 180 degrees longitude is not there, no? This is what we discussed. This is 82.5 degree meridian. Here, here is where Australia is there. Let's say this slide we are taking up. So, Now take this. This is okay, what? This is nothing but okay, where India is having like this. Let's say this is 82.5 degree meridian. Fine. 82.5 degree meridian. Now what will be the meridian at over here?
Further.
Ahead. Let's say around 110 degree meridian will be there. Okay, but how much is the difference now between 82.5 degree and around 28 degree difference in meridian? 28 degree means difference means how much difference in time? Roughly 2 hours. So you are going to lose 2 hours, not you are not going to lose day. Fine.
In the ideal time,
When you are moving across 180 degree, then you are losing what? Then you are losing day or gaining a day. Not normal. Okay, this thing. Fine.
so this will be different after. So when more across the meridian line, a person loses the day.
Moving across a meridian line, prime meridian.
Prime meridian latitude lines.
Huh.
Person loses the day.
Not loses a day, loses hours, not day. Fine.
From west to east.
That you can.
Like for example, from Russia to Alaska, they will be changed.
Day will be changed. Day will be changed. That is across ideal. Fine. So this is all about what? This is all about the different thing that you have to keep in mind with regard to what? With regard to isotherm, with regard to temperature distributions and etc. Any doubt regarding this one? I will just exit this. Now fourth you try to answer. So it is saying which of the following is our correct inferences from isothermal map in the month of January. So January means where the sun position will be there. Where the sun position is going to be there in the month of January. Where the sun position is going to be there in month of January. We discussed when winter solstice occur. When winter solstice occur on which date? 22nd December. So at 22nd December, winter solstice sun position is over here. So at January, what will happen? Sun position will be here, somewhere near to what? Near to nothing but okay, Tropic of Capricorn. Why? Because equinoxes will come on 21st March. And sun position will go over here and 21st June, that is okay there. So in the month of January, sun position is okay, going to be there at Going to be there at near to the Tropic of Capricorn. Fine. So when sun position is here, what will northern hemisphere will face? Winter condition. What will the southern hemisphere will face? Summer conditions. Okay, so when sun position is here, what northern hemisphere is going to face is winter condition. What southern hemisphere is going to face is a summer condition. Now see, in winter, what we have written? Where the position of in winter, where do you see isotherm is north or isotherm is south over continent? See, in northern hemisphere in winter condition, isotherm is north over continent or isotherm is south over continent. In northern hemisphere in winter condition, isotherm is north or isotherm is south? South over which one? Oceans or south over continents? South over oceans. And north over what? North over continent. This is a condition you are getting in the, is it correct? Winter condition, what you are getting? See and tell me what is there, what you are getting in the, just now we have written in winter condition in northern hemisphere, where you see isotherm, northward side or southward side? Equator words towards continent. Equator word means southward side. Equator we have written southward, or equator word towards where? Continent. So you'll see this is okay there, while the you'll see what? Northward shifting. Here you'll see which type of shifting? Northward shifting. Clear? What will happen in the southern hemisphere? See, southern hemisphere, where shifting is happening, north or south? Where shifting is happening, north or south? Summer condition. In southern hemisphere, you have to see southern summer condition, not winter condition. Northward over? Northward over continent and southward over oceans. Fine. Now just see first statement what it says. Isotherm deviates to the north over the ocean and south over what? South over the continent. Clear? So what is happening? Is it correct statement or is it wrong statement? Correct statement. Isotherm deviate to the north over the ocean and south over what? South over nothing but okay, continent. That is okay there. Clear? The second is what? The presence of cold oceanic current like Gulf Stream, North Atlantic Drift. So these current name that are given, Gulf Stream, North Atlantic Drift, these are which type of current it is mentioned? Cold oceanic current, that is okay mentioned. Now, if you see the, I'll just see oceanic current because you have not studied oceanic current till now. So if you see oceanic current, so you see this is a map that you are getting with regard to oceanic current. So this you are finding the map with regard to what? With regard to oceanic current. Now here you can see which current is mentioned, Gulf Stream. Now wherever okay you are seeing red color, all these red colors are which type of current? Warm current. And all these okay the blue color are which type of current? Cold current. All these blue colors are, so Gulf Stream is which type of current? Warm current. What question is mentioning? What question is mentioning? It's mentioning Gulf Stream as which type of current? It is mentioning Gulf Stream as a cold current. Yes, okay. So it is mentioning Gulf Stream as a cold current. So it is saying the presence of cold oceanic current. Cold oceanic current. Gulf Stream is not a cold oceanic current. So that's why second statement is what? Wrong statement. That is okay there. So this is how you have to keep in mind with regard to concept of the isotherms. Okay, so like this questions can be asked in the examination regarding isotherm, where isotherm will be placed, whether it is in northward direction or whether it is going to be in southward direction. In exam, if you are not remembering the points where isotherm is deviating, if you know the concept, you can easily make it. So we discussed, okay, what is happening in the northern January month means what? Isotherm. How we will make the diagram? So we discussed January month means the sun position is going to be here. So what will happen in northern hemisphere? We discussed the winter condition. Winter condition means what will happen over here? The land will be much cooler. So let's say here 10 degrees Celsius is there. So at the ocean, what will happen? We'll have 15 degrees Celsius, okay, over here, 10 degree over here, and 15 degree over here. That is okay there. So here what is happening? It is deviating towards what? Deviating towards nothing but okay south. It is deviating towards nothing but okay north. You can make this particular diagram in the case of examinations. Fine. Any doubt regarding this particular part? So this is how, okay, you are going to get questions regarding what? Regarding nothing but okay isotherms. Fine. Clear? So remember the term whenever, okay, we are talking about isosysmic or isotherms. Again, we'll discuss one more line called isobar. Isobar, bar means what? Pressure. So all these are the lines that are drawn on a map to indicate what? To indicate change in temperature or change in pressure or change in, okay, the intensity of earthquake. So that you keep in mind. Fine? Yeah. Yeah. You go and practice. If you are not getting, I'll explain. Now, next is what? Next is your concept of heat budget. Next is a concept of heat budget. Let's say this is a Earth's surface. We are talking about this as a Earth's surface. Now you'll see the sun. From the sun, what is coming? Solar radiations are coming. Solar radiations are coming. Some of these radiations are going to be, now let's say this is okay, what? This is atmosphere. This part is atmosphere. So some of this energy will be radiated by the atmosphere. Some of the solar energy will be radiated by the clouds. And some of the solar radiations will be reflected by the Earth's surface. Reflected by Earth's surface. Reflected by clouds. Reflected by atmosphere. By atmosphere. Clear? So we are taking this as 100 unit. How much? 100 unit is okay, what? Coming from the sun. We are taking this as 100 unit, which is solar radiation coming from the sun. Now some amount of this radiation, let's say this is -6 unit, -27 unit, and -2 unit. So this is going to be what? This is going to be radiated. This will not reach to or not absorbed by the Earth's surface. Okay. So -6 unit reflected by the atmosphere. Around, okay, what? -27 unit you will see, okay, reflected by whom? Clouds. And you'll see reflected by Earth's surface. You know that we discussed concept of what? Albedo. That some amount of energy radiations are going to be reflected by whom? Reflected by the Earth's surface. So that is called as a Earth's albedo. So total -35 unit is something that is okay reflected. Clear? Now if we discussed one more thing, that if atmosphere is what? if atmosphere is not transparent, transparency of atmosphere we discussed. So in the atmosphere, lot of particles are being present. In lot of particles are being present, what will happen? We discussed scattering is happening, reflection is happening, and some absorption also is happening. No? When absorption happens, when absorption happens, when absorption happens, what we have written, if wavelength is equals to what? If wavelength is equals to radius of whom? Radius of obstructing particle, what will happen? Absorption happens. Go back to transparency of atmosphere. So we discussed temperature distribution effect, no? So there we have written transparency of atmosphere. So when atmosphere is okay, whatever the sun's radiation is coming, if this radiation is equals to radius of obstructing particle, then what will happen? Then absorption is going to happen. So some amount of absorption is also going to happen, and this is equals to 14 unit. So this is equals to how much unit? 14 unit, that is okay, being absorbed by the atmosphere. Fine. So some amount is reflected, some amount is scattered, and some amount is okay, some amount is absorbed. So what will happen is, okay, if sun is from the sun 100 unit, okay, 100 unit is being intercepted by the earth. Out of this, you see 35 unit and you see this 14 unit. These are not reaching to the earth surface itself. They are being reflected by the earth surface. So earth is ultimately going to absorb how much energy? Out of 100, if you minus 49, how much will be left? 51 unit. So ultimately earth will absorb how much unit? Earth will absorb this much unit. Earth will absorb this much unit. So how much unit is being absorbed by the earth surface? Earth is absorbing 51 unit. So you see, half of the sunlight which is being intercepted by the earth is not being absorbed by the earth. It is being what? It is being nothing but, okay, reflected, refracted, or absorbed in the case of atmosphere. That is okay there. Fine. Fine. So this 51 unit, that is okay, being absorbed by the earth, will now be reflected by the earth. So this type of radiation is called as what? So this is we call as a incoming radiations. This we call it as a incoming radiation coming from the sun, and this is called as what? Outgoing radiation. Outgoing radiation. So outgoing radiation is which radiation? It is going to be terrestrial radiation. Terrestrial means what? From the earth. And incoming radiation is which radiation? It is solar radiation. It is which radiation? It is solar radiation. So incoming radiation is which radiation? Solar radiation. Outgoing radiation is which radiation? Terrestrial radiation. Fine. So now this 51 unit which is reaching to Earth's surface, this 51 unit which is reaching to the Earth's surface, absorbed by the Earth's surface, out of this 51 unit, 34 unit will be again radiated by what? Radiated by the Earth, and this 34 unit is going to be absorbed by the atmosphere. Absorbed by the atmosphere. And the rest 17 unit will escape into inward space. 17 unit escape into space. This is escaping into space. So 34 unit is what? 34 unit is absorbed by whom? Absorbed by atmosphere, and the 17 unit will escape into space. Now why it will be absorbed? You know that greenhouse gases and other gases are something that are present, so they will absorb nothing but, okay, terrestrial radiations. Clear? Any doubt regarding this one? So atmosphere is absorbing which type of radiation more? Atmosphere is absorbing which type of radiation more? Incoming radiation or outgoing radiation? They are absorbing outgoing radiation more. Yes, atmosphere is absorbing outgoing radiation more than incoming radiation. That's why we discuss atmosphere is heated more by whom? It is heated more by terrestrial radiation or Earth's radiation terrestrial radiation or Earth's radiation, then sun's radiation. Then sun's radiation. Fine. This 14 unit, yes. See, this is okay. What? When atmosphere, we discuss if many particles are present in the atmosphere, no? As we discuss, if sun's wavelength is equals to what? Radius of obstructing particle, then what will happen? Absorption will take place. So if atmosphere is not transparent, many obstructing particles are going to be there. When these are obstructing particles going to what? Absorb certain radiation. How much radiation they are absorbing? 14 unit they are absorbing. So total unit, how much Earth is receiving? 51 unit. How much radiation Earth is radiating? Total also the Earth is radiating is 51 unit, 17 unit and 34 unit. Total how much Earth is also radiating? 51 unit. So that's why we say sun's radiation or solar radiation is what? Solar radiation comes in the form of short wave. They come in the form of short wave. That's why atmosphere is not able to absorb. That's why atmosphere is not able to absorb much of these radiations. Much of these radiations. But Earth's radiation is mostly in form of long wave. Earth's radiation is mostly in the form of long wave, and that's why atmosphere absorbs a lot of these radiations. Atmosphere absorbs a lot of these radiation. That's why atmosphere is more heated, 34 unit by the Earth's surface rather than 14 unit by the sun's radiations. Fine. Fine. So this entire scenario is called as a heat budget. So you see how much sunlight we are intercepting. How much sunlight we are intercepting is called as what? Solar insolation. How much we are intercepting? 100 unit. Out of this 100 unit, how much reaching to the Earth? Only 51 unit. Rest are nothing but what? Rest are being reflected, absorbed in the atmosphere, and this 51 unit that is being reaching to the Earth's surface. Either it can be what? Either it can be radiated, that is 34 unit will be radiated into the atmosphere, and others 17 unit will escape into the atmosphere. So total radiation, how much is absorbed by the atmosphere? 14 by incoming and 34 by outgoing. So total it is absorbed is 48 units.
This will ask in mains.
Yeah, concept of heat budget will be asked in mains
Then
exam.
we should draw the center diagram.
Yeah, you have to draw this entire diagram. Now, what is happening if question comes? Why this climate change is happening? Now, this heat budget is maintaining what? This heat budget is saying that Earth, how much Earth is receiving, Earth is radiating that much. Clear? But what if this atmosphere starts to absorb more amount of unit? Currently, it is absorbing how much unit? 34 unit. If it starts to absorb more number of unit which are escaping into the atmosphere, if it is also absorbing that also, what will happen? Then climate change will happen, global warming will happen, which is happening. Now, greenhouse gases, we are releasing more number of greenhouse gases. More number of greenhouse gases means what? Now more absorption of radiation are going to happen. When more absorption of radiation are going to happen, atmosphere will now absorb more radiation. When atmosphere will absorb more radiation, what will happen? Temperature will what? Temperature will increase, and this will cause what we call a global warming. Fine. So have a break and then we'll further continue.
So that is terrestrial radiation or Earth's radiation.
Yeah, terrestrial radiation or Earth's radiation.
What's the chapter? And okay, 27. Images of this. 27. Cloud. I mean, the reflex is 27 minutes. 35. Reflected by the atmosphere. You want to say what? 9 30. 9:30. ಇಲ್ಲ 9:30 ಬರ್ತೀವಿ.
Monday, I'll provide Monday.
Tomorrow, again,
Yeah, tomorrow again is test. Tomorrow you'll be having plate tectonics. For mains, you study plate tectonics, the theory is part, and you study the atmospheric structures and etc. Heat budget. This you study for the mains part. For prelims, revise entire. Okay. No, not asked questions regarding plate tectonics. So we have not covered seafloor spreading plate tectonics mains questions. Fine. So you cover that part. You cover heat budget. You cover atmospheric structures and functions. And for prelims, you just try to revise everything.
One question, sir, we have this topic.
Hmm?
I mean, heat budget, not heat budget, sorry. This hemispheres.
Hemisphere, northern hemisphere, southern is isotherm part.
Yes.
Isotherms you can get in the prelims question. As a prelims question, you can get isotherm. Fine. So basically, when we are using the term budget, what is the term budget means? Generally, you use the term budget in economics. What the term budget means? Annual financial statement. What does it contain? It contain. What does an annual financial statement contains?
coming year, financials.
It contains expenditure, layout of expenditure and revenue, from where you are going to get the revenue and from where you are going to spend the money. So when we are talking about the term heat budget, we are dealing with what? From where we are getting the energy and from where the energy is outgoing, that is called as a heat budget. Simple term, heat budget is all about what? Heat budget is all about, it is a keeping a record of what? Keeping a record of whatever the energy that you are getting and whatever the energy the earth is radiating. That concept is referred as what? That concept is referred as a heat budget. Fine. So next is a concept of lapse rate. What is a lapse rate? Lapse rate is a decline. It is a decline in temperature. At what rate decline in temperature is something that is okay happening? This is referred as what? This is referred as a lapse rate. Clear? So at what rate decline in temperature is happening? Decline in temperature is happening. At what rate is referred as what? Is referred as a lapse rate. Fine. So at what rate decline in temperature is happening is referred as what? Is referred as a lapse rate. Fine. There are two types of lapse rate. One is called as a normal lapse rate and another is called as a adiabatic lapse rate. So one is referred as what? One is referred as a normal lapse rate, another is referred as what? Adiabatic lapse rate. The normal lapse rate applies to non-rising air, while adiabatic lapse rate applies to the rising parcel of air. So the main difference that applies to normal lapse rate applies to non-rising air and adiabatic lapse rate applies to rising parcel of air. Fine. Fine. So as you go up in troposphere, we discuss with increase in height what happens? Temperature declines. This is called as what? This is called as a lapse rate or normal lapse rate or also referred as an environmental lapse rate. So this is also referred as an environmental lapse rate. Normal lapse rate is also referred as an environmental lapse rate. So as you go up in troposphere, temperature declines, and this is referred as a lapse rate. If you go up and temperature do not declines, rather remains constant. So if you go up and temperature do not declines, rather remains constant, then it is going to be called as what? Then it is going to be called as what? Then it is going to be called as zero lapse rate. It is referred as a zero lapse rate. Zero lapse rate. And if it is okay, what? As you are going up and temperature is increasing, then it is called as what? It's called as a negative lapse rate, or phenomena of temperature inversion. Temperature inversion. So these lapse rate, you concept of lapse rate you keep in mind. As you go up and temperature decreases, then it is called as a normal lapse rate, or it is called as a environmental lapse rate. As you go up, temperature do not decline, rather temperature remains constant, then it is going to be called as what? It is going to be called as a zero lapse rate, neither increasing nor decreasing, then it is going to be called as a zero lapse rate. And as you go up, if temperature start increasing, then it is going to be called as what? Negative lapse rate, and this is okay called as a temperature inversion phenomena. It is referred as which phenomena? Temperature inversion phenomena. Fine. Fine. So we discussed, we have a two concept, non-rising air as well as rising parcel of air. Non-rising air and rising parcel of air. So you have normal lapse rate and you have adiabatic lapse rate. Fine. What does the term non-rising air means? Let's say this is the Earth's surface. Then you see, we discuss here is what? Here is a air parcel. Like this air parcel are there. This air parcel remain as it is. This is called as what? This is called as a non-rising air. Clear? This is called as which type of air? Non-rising air. But let's say if you boil something, if you are boiling something, what will happen? You see vapor rising, no? Vapor rising. So there is a air parcel which is rising in nature, and there is a air parcel which is not rising in nature. So this is a air parcel which is rising, but there is a air parcel which is not rising. So these are non-rising air. Well, these are nothing but okay, what? These are nothing but okay, rising air. This is rising air. These are non-rising air. Fine. So you see vapor rising like this. Whenever you heat something, you see something vapor going up. So what is happening is atmosphere is there. Here already gases are present. Gases are present. Those are non-rising air. Then the one that rises is called as what? Rising air. So in rising air, you're going to see which type of lapse rate? In rising air, you're going to see adiabatic lapse rate. Here you see which type of lapse rate? Non-rising air. You're going to see nothing but okay, the normal lapse rate. Fine. So as you go up and temperature starts to decline, then it is called as a normal lapse rate. Generally it declines with 6.5 degrees Celsius per kilometer. At this rate, generally it is declining. Clear? So as we are moving 1 kilometer above the Earth's surface, how much temperature decrease is happening? 6.5 degrees Celsius. Further increase, we discuss 6.5 degrees Celsius. So if it is declining at 6.5 degrees Celsius per kilometer, then it is going to be called as what? It is going to be called as a normal lapse rate. Fine. And the second type of lapse rate is called as a adiabatic lapse rate. Fine. Which happens in which type of air? Rising air. Fine. Now there are few things that you have to keep in mind. There's a certain laws, two important laws that you have to keep in mind is Boyle's law and Charles' law. So in chemistry, there is a certain laws One is called as a Boyle's law, which talks about relationship between volume and pressure. Volume of a gas, all these are gas laws. All these are related to gas. Fine. So it says volume is inversely proportional to what? Volume is inversely proportional to pressure. Volume of a gas is inversely proportional to pressure. Charles' law says while volume of a gas is directly proportional to what? Directly proportional to temperature. And when we are combining all these laws, we are getting this equation, which is called as a PV is equals to nRT. RT stand for temperature, P stand for what? Pressure, V stand for volume. R is a universal gas constant. So this is what we called as a ideal gas equation. This is called as a ideal gas equation. Fine. Now to see its application, for example, we are saying, let's say you are okay. What you are blowing a balloon. If you are blowing a balloon, what happens? It expands. Balloon expands. So what is happening? Its volume is changing. So when you are okay, what? When you are nothing but okay, applying what? Applying the pressure. You are giving pressure to the balloon. What is happening? Its volume is something that is okay, expanding. But okay, what will happen is okay, what? There is no heating as temperature is not constant. As temperature is not constant. But same thing, same pressure if you apply in a tire tube, what will happen? Tire tube, you try to apply, okay, fill air in a tire tube, what will happen? It will not expand. Why it will not expand? Because volume is what? Volume is not expanding. So what is happening is there is a relationship that you are also getting from this, that is pressure and temperature. Pressure and temperature are which type of related? They are directly related. Pressure and temperature are which type of related? Direct relation if volume is constant. If volume is not changing, then there is a direct relationship between what? Pressure and temperature. In balloon, you are applying a pressure, but since volume is changing, you see no increase in what? No increase in temperature of balloon. But in case of okay, car tire, when you are applying a pressure, what is happening? Volume is not changing. When volume is not changing, what will happen to temperature? It will increase. And that's why if you keep on applying pressure on in a car tube, what will happen? What will happen? It will burst. Why it will burst? Because temperature is constantly increasing. When temperature will increasing, that tire will get burst. Fine. So this is what you have to keep in mind with regard to laws, which applies to whom? Which applies to the gases. These are the laws which applies to gases. Fine. So when an air rises, what happens? When air is rising, what will happen? What will happen? We discussed these are non-rising air. So I'll just make the diagram with different color. So these are non-rising parcel of air. These are non-rising parcel of air. And this is rising parcel of air. Air is here is rising. This is a rising parcel of air. Fine. Now, when this air parcel is rising, what will happen? What will happen? Where you have more pressure. Pressure is more at the Earth's surface, or as you go up, there is more pressure. Where do you find more pressure? At the Earth's surface, or as you go up, you will find more pressure? As you go up, you will find more pressure. Why? Why? Why do you think as you go up, you will find more pressure? Anyone else? We have discussed atmospheric structure and composition. No? We discussed more heavier gases are where? Near to the surface. As you go up, what will happen? Lighter gases are there. If lighter gases are there, they are going to apply what? Less pressure. Pressure is what? Pressure is force per unit area. How much force is applying? When you have lighter weight, will apply less force. When you have heavier weight, what will happen? Will apply more force. So more force is applied where? More force is applied near to what? Near to nothing but okay, this one. As you go up, what will happen? Pressure will decline. Clear? As you go up, what will happen to pressure? Pressure will nothing but okay decline. Pressure is more where? Pressure is more near to the earth's surface. It is more near to the earth's surface. As you go up, pressure will decline. That's why you face difficulty in breathing when you climb mountains. Why? No air. No air means what? Okay, no pressure. No pressure means what? Will not be able to breathe oxygen. That's why you see oxygen cylinders and other cylinders are taken by mountaineers. Fine. Any doubt regarding this one? So what you have to keep in mind is pressure is what? Pressure is more where? Near to the earth's surface. As you go up, what will happen to the pressure? Pressure will decrease. As you go up, pressure will decrease. Fine. Any doubt regarding this part? So as the air parcel is going, what will happen to this air parcel? You will see decline in what? Decline in pressure, because air parcel here will experience more pressure. As air parcel will go up, what will happen? Decline in pressure, because as we go up, we are saying pressure will decline. If pressure decline, what will happen to temperature? If pressure decline, what will happen to temperature? Temperature will also decline. If temperature will also decline. Clear? So as you are going up, what is happening? Pressure is declining. When pressure will decline, what will happen to temperature? Temperature will also decline, because there is a direct relationship between whom? Pressure and temperature. Fine. So when temperature will also decline, what will happen to the gas? What will happen to the gas? This gas which is rising, what will happen to this gas? They will lose what? They lose heat or temperature. Decline in temperature will happen, no? Decline in temperature will happen. Why decline in temperature is happening? Because as pressure will decline, what will happen to temperature? Temperature will also decline. This decline in temperature is referred as which type of lapse rate? It is referred as which type of lapse rate? Adiabatic lapse rate. It is referred as which type of lapse rate? Adiabatic lapse rate. Fine. Any doubt regarding this one? So what we are saying is what? When our air parcel is rising, when air parcel will rise, what will happen? Pressure will decrease. As you go up, pressure will decrease. When pressure will decrease, what will happen? When pressure will decrease, what will happen? What will happen? Temperature will also decline. When temperature will decline, what will happen? You'll see gas will lose, okay, what? Gas will lose its temperature, and this loss of temperature or decline in temperature is referred as which type of lapse rate? Adiabatic lapse rate. So adiabatic lapse rate is seen in which type of, okay, air? Rising air. Normal lapse rate is being seen in which type of layer? In the not rising air. Fine. Any doubt regarding this particular part? Now, another important aspect that you have to keep in mind, whenever adiabatic lapse rate are there, there will not be, in this type of lapse rate, adiabatic lapse rate, there will not be any exchange of heat. Any exchange of heat between system and surrounding. There will not be any exchange of heat between system and surrounding. Fine. So what will happen in adiabatic lapse rate? There will not be any change. There will not be any exchange of heat between system and surrounding. Clear? So in case of, okay, what? In case of physics, there is a chapter called thermodynamics. Thermodynamics talks about this type of lapse, okay, rate, or this type of system called as adiabatic system. So in adiabatic system, there will not be any exchange of heat that is going to happen between what? System and surrounding. Clear? For example, if I am holding ice in my hand, what will happen? If I am holding ice in my hand, what will happen? What will happen? You will see my hand will what? My hand will become, okay, colder. Why it becomes colder? Because transfer of heat is happening between system. System is what? Ice, and surrounding. Surrounding is what? My hand. So if exchange of heat is happening between system and surrounding, that is called as what? That is called as a non-adiabatic process. But if there is no exchange of heat happens, then it is going to be called as what? Then it is going to be called as a adiabatic process. Clear? So here this rising parcel of air is not losing energy because of what? Because of transfer of heat between this air and this air. Transfer of heat is not happening between this air and this air. What is why it is cooling down? Why is cooling down? Because when it is rising, what is happening? Pressure is declining. When pressure is declining, what will happen to temperature? Temperature will decline. So there is no exchange of heat happening between system and surrounding. When there is no exchange of heat happens between system and surrounding, such type of lapse rate are referred as what? Such type of lapse rate are referred as a adiabatic lapse rate. Fine. Any doubt regarding this one? So what is the difference between normal lapse rate and adiabatic lapse rate? Normal lapse rate is decline in temperature of non-rising air, while adiabatic lapse rate is what? Decline in temperature of rising parcel of air. Why this decline in temperature happens? This decline in temperature happens because decline in pressure. If pressure will decline, what will happen to temperature? It will also decline, and there will not be any exchange of heat happens between system and surrounding. So such type of lapse rate are referred as what? Such type of lapse rate are referred as a adiabatic lapse rate. Any doubt regarding this one? Anyone having any doubt? Fine. Now, adiabatic lapse rate can be further divided into two types. They can be further divided into what? Two types. Dry adiabatic lapse rate. Dry adiabatic lapse rate or wet adiabatic lapse rate. Fine. It is divided into two types, dry adiabatic lapse rate or wet adiabatic lapse rate. The dry adiabatic lapse rate occurs in unsaturated. It occurs in unsaturated air, and wet adiabatic lapse rate occurs in saturated air. Clear? So dry adiabatic lapse rate occurs where? It occurs in unsaturated air, and wet adiabatic lapse rate occurs in which type of air? Saturated air. Clear? What is the difference between saturated and unsaturated air? Contain of water. Yes. So as we discussed, air contains what? Air contains what? Air contains water vapor. Suppose air has holded maximum amount of water vapor that it can hold. 100% water vapor it has holded what it can hold. Then such type of air is going to be called as what? Saturated air. The maximum water vapor that air can hold, if it is holding that much, then it is going to be called as which layer? Which type of air? Saturated air. If it is holding less than 100%, 90%, 80%, 60%, then it is going to be called as which air? It is going to be called as a unsaturated air. Clear? So how much moisture air is holding, that will decide what? That will decide whether it is saturated air or whether it is unsaturated air. If maximum capacity they are holding, then it is going to be called as a saturated. If less than maximum capacity, then it is going to be called as a unsaturated air. Fine. Fine. Clear? Now we are discussing, this is a rising parcel of air which is rising. Yes, adiabatically it is rising. And what you see is, this is what? Non-rising parcel of air. This is non-rising parcel of air. Fine. Now, till what point this will rise? Till what extent this air will rise? Till what extent? Up to what height it is going to rise?
Till the temperature and pressure.
Till where the temperature and pressure are equal. There you are seeing.
At what capacity it can hold the temperature?
At what capacity air can hold temperature and pressure? No, air is holding moisture. Air is holding moisture. Air is having certain temperature and pressure. Like your body is having certain temperature, no, 37 degrees Celsius. So you are not holding that temperature. That is okay. What? That is your body mechanism. 37 degrees Celsius temperature is something that is okay there. Likewise, air also have a certain temperature. Fine. It is holding what? It is holding the moisture. It is holding the moisture. Fine. Up to what height you see it is going to rise? Which principle will apply over here? Which principle will apply? Up to what height it is going to rise? It will rise up to a point till the time rising parcel of air is what? This air is lighter than which air? Than the surrounding air. Till the time it is lighter than the surrounding air, what will happen? It will rise. You know that less dense object float over what? More dense. We have discussed less dense object is going to float over what? More dense object. Okay, that is okay there. So if air is less dense, then lighter in nature, it is less than, then it is going to rise up. That okay, the point where the okay what? Where the air becomes what? Air becomes equals to nothing but okay, this one, it will stop rising. It will stop rising. So why air is rising up? Why air is rising up? Because it is less dense. Less dense means what? Density is what? What is density? We discussed density is mass by volume. If volume increases, what will happen to density? What will happen to density? Density will decrease. The object will become what? Lighter in nature. What is density? We discussed density is nothing but okay, mass by volume. If volume increases, what will happen to density? It becomes, density will decrease because inverse proportional. So what will happen? This air will become what? Lighter in nature. And when volume will increase? When volume will increase? When volume will increase? We discuss when you are going to what? When you are going to increase the temperature. If temperature is increasing, then what will happen to volume? Increase. That's why we say when air is heated, what will happen? It will expand. Okay, why? Because volume is increasing. When you are increasing nothing but okay, the temperature, that is okay there. Clear? Any doubt regarding this one? So when the air is going to be more when the air is going to be less dense, when the air is going to be less dense, when it has more volume, when it will have more volume, when it will have more temperature. So when air is heated, you see air is rising up. Till the time you see air is what? Air is heated than the surrounding air, it will rise up. The moment okay, air will cools down, because as we discussed, they are rising. When you are rising, what will happen? Pressure will decline. Pressure will decline means what? Temperature will decline. So your temperature becomes equals to surrounding air, and when temperature becomes equals to surrounding air, you will not rise, you will stop rising. Any doubt regarding this particular part? So this is what we call as okay, what? This is what we call as a concept of adiabatic lapse rate. Fine. Any doubt regarding this particular thing? Now what this saturated and unsaturated air is doing, for this to understand, we have to understand one more type of heat, which is called as a latent heat. You have to understand one more type of heat, which is referred as what? Latent heat. Fine. We have discussed specific heat. What is specific heat? Yeah, amount of heat requires to raise the temperature of a body by what? 1 degree Celsius. That is going to be called as what? Specific heat. What is a latent heat? The amount of heat. It is amount of heat required. Amount of heat required to change the state of the body. Amount of heat requires to change the state of a body is going to be called as what? Is going to be called as a latent heat. Fine. Amount of heat that is required to change the state of a body is called as what? Is called as a latent heat. Fine. Let's say ice is at this temperature. At this temperature, you have kept an ice minus 20 degrees Celsius. Now you are providing heat to the ice. Now you are providing heat to the ice. You are heating the ice. What will happen? It will melt. Immediately it will melt? No. Till what point it will not melt? Ice is kept at minus 20 degrees Celsius. Now you are applying heat to the ice. Immediately it will melt, or okay, it will melt after a certain point of time? Certain point of time. How much time? 10 seconds, 20 seconds. Then how you are calculating this 10 second, 20 second? Based on observation. Huh? Anyone else? Anyone else? What is the melting point of water? A melting point of ice. What is the melting point of ice? What is melting point of ice? What is boiling point of water?
Boiling point of 100.
Boiling point is 100 degrees Celsius. Melting point is what? 0 degrees Celsius. Okay, so melting point is what? 0 degrees Celsius. Boiling point is what? 100 degrees Celsius. Clear? So what will happen is, okay, what will happen is, so you have, this is a boiling point and this is what? This is nothing but, okay, melting point. Fine. So when you are applying heat, what this heat will do, this will not melt the ice. What this heat will do, it will increase the temperature of ice from -20 to -19 to -18 to -17 till the time ice reaches to which temperature? 0 degrees Celsius. Okay, when ice reaches to 0 degrees Celsius, then what will happen? It will start melting, because this is a melting point. Below this, ice will not melt. So this is a melting point. So when you are applying heat, this heat is being utilized for what? When you are applying heat, this heat is being utilized for raising the temperature of a body from -20, it is okay, what, -19 to -18. So such type of heat is called as what? Such type of heat is called as what? Specific heat. When you raise the temperature of a body by 1 degree Celsius, we call it as which type of heat? Specific heat. So when you are heating the ice, whatever heat is being absorbed, it is a specific heat and it is raising the body temperature of a body by what? 1 degree Celsius till it reaches to which point? Till it reaches 0 degrees Celsius. Now, when ice reaches to 0 degrees Celsius, when this ice reaches to 0 degrees Celsius, now when you are applying heat, what will happen? What will happen? Now this ice will starts to melt. As we discussed, it is a melting point. So when ice is reaching to 0 degrees Celsius, now when you are applying heat, what will happen? Ice will starts to melt. So ice is melting from which? From solid to, it is changing its state. It is changing its state from solid, it is becoming what? Liquid in nature. So whatever heat that are going to absorb at this point of time, whatever heat that are going to absorb at this point of time will not raise the temperature from 0 to 1. It will not raise the temperature from 0 to 1. It will change the state from what? From solid to nothing but, okay, liquid. Clear? And such type of heat is referred as which heat? Latent heat. Such type of heat is referred as a latent heat. So amount of heat required to change the state of the body is called as a latent heat. Clear? Fine. Any doubt regarding this one? So that's why when it is occurring at this point, it is called as what? It is called as a latent heat of condensation. Latent heat of condensation. Fine. Fine. So it is referred as which type of condensation? Latent heat of condensation. So till the time all the ice is not converted into water, you see no increase will be there in temperature. 0 degrees Celsius only will be there, and whatever heat you are providing will convert ice into nothing but, okay, water. Once it is converted into water, then what will happen? When you apply further heat, what will happen? Now it will starts to raise the temperature to 1 degree, 2 degree, 3 degree till the time it is reaching which one? Till the time it is reaching 100 degrees Celsius. When water temperature will reach to this point, then what will happen? Whatever extra heat that you are providing will convert water into which form? Vapor form. And that's why this again is changing the state of the body. From liquid you are moving towards which? Gaseous form. So whatever heat that is absorbed over here is called as what? Is called as a latent heat of vaporization. It is called as what? Latent heat of vaporization. It is referred as what? It is referred as a latent heat of vaporization. Fine. So clear the concept between specific heat and a latent heat. What is specific heat? Amount of heat requires to raise the temperature of a body by what? By 1 degree Celsius. What is latent heat? Amount of heat requires to change the state of a body, that is called as a latent heat. Fine. Any doubt? Fine. Now come to the previous slide. What you are finding, we discussed, as the air is going up, what will happen? As the air is going up, what will happen? Pressure will decline. When pressure will decline, what will happen? Temperature will decline. Clear? As we discussed, as you are going up, what is happening? Pressure is declining. When pressure is declining, temperature will also decline. When temperature will decline, what will happen to volume? Decline, because we discussed there is a direct relationship between volume and temperature. Volume will decline. When volume will decline, what will happen to density? Density will increase. When density increase, what will happen? You don't see nothing but, okay, what? You don't see air rising, because, okay, it has now become equal dense. So it will not rise up. So this is how the rising of air stops. Fine. Now this air contains lot of moisture. This air contains lot of moisture, because we discussed saturated air and unsaturated air. So this air contains moistures. Fine. Rising air is containing moisture. Now what will happen if this air is going up? As we discussed, pressure is declining. Pressure is declining means what? Temperature will decline. What will happen to this moisture which is in vapor form? What will happen to this moisture which is in vapor form? If temperature will decline, vapor means what? Vapor means what? Vapor means gaseous state. So if temperature will decline, what will happen? It will come down in which state? Moisture will come down in which state? Moisture is going to come down from gaseous to which state? Liquid state. And whenever, okay, any object is going to from gaseous to liquid, what will happen? What heat is going to be released? What heat is going to be released? Latent heat is going to be released. Now this heat will again what? This heat will again heat up the air, because heat is being released. It will heat up the air. When heating will happen, what will happen to temperature? Increases. What will happen to volume? It will increase. When volume increases, what will happen to density? It will decrease. So again the air will start to rise up, because of release of which heat? Because of release of latent heat. Clear? So when air is what? When air is rising, after the release of latent heat, then such type of lapse rate is referred as what? Then such type of lapse rate is referred as a wet adiabatic lapse rate, because rainfall is going to happen. After that, air will rise, because rainfall is happening. Why? Because the water vapor is converting from gas to liquid. This liquid water will come down. So when air will, okay, rise after what? After release of latent heat, and as we discussed, as it goes up again, pressure will decline, temperature will decline, air will become what? Air will become less dense. So that's why when the decline in temperature is going to happen, when air is rising after the latent heat and decline in temperature happens, then such type of things are called as what? Then such type of things are called as a wet adiabatic lapse rate. Clear? When decline in temperature happens, without release of latent heat, then it is going to be called as what? It is going to be called as a dry adiabatic lapse rate. So here decline in temperature is happening after release of latent heat, then it is going to be called as a wet adiabatic lapse rate. If decline in temperature is happening without release of latent heat, then it is going to be called as what? Dry adiabatic lapse rate. Fine. Fine. So this is what the concept of lapse rate is all about. Lapse rate means what? Lapse rate simply means what? As you go up, there should be decline in temperature. This is called as a lapse rate. There are two different of lapse rate. One is what? Normal lapse rate or environmental lapse rate. Second is what called as a adiabatic lapse rate. Normal lapse rate occurs in which type of air? Non-rising air. Adiabatic lapse rate occurs in which type of air? Rising air. The rising air, when air is rising, what will happen to pressure? Pressure will decline. When pressure will decline, what will happen to temperature? Temperature will decline. When temperature will decline, what will happen? Volume decreases, air will become more dense, and this will stop rising. Fine. When water is there, water vapor is there in this particular air, what will happen? This water vapor will condense into what? Condense into water. It will release the latent heat. When it will release the latent heat, air will further rise up. When air will further rise up, what will happen? Further pressure decline. When further pressure decline, further temperature decline, and such type of lapse rate are going to be called as what? Wet adiabatic lapse rate. If it is happening before the release of latent heat, then it is going to be called as what? Dry adiabatic lapse rate. So that's why you have two kind of lapse rate, dry adiabatic lapse rate and wet adiabatic lapse rate. So we discussed the environmental lapse rate. Non-rising air is declining at which rate? 6.5 degrees Celsius per kilometer. The dry adiabatic lapse rate is around 9.8 degrees Celsius per kilometer. It is around this much decline, while the wet adiabatic lapse rate is around 4 degrees Celsius per kilometer. Decline generally is seen around 4 degrees Celsius per kilometer. So here it is 9.8 degrees Celsius per kilometer. Here the decline is happening around 4 degrees Celsius per kilometer. Fine. 4 degrees Celsius per kilometer. That's why you have what? You have dry adiabatic lapse rate greater than what? Environmental lapse rate or normal lapse rate, which is greater than what? Wet adiabatic lapse rate, because it is declining at which? It is declining at 9.8 degrees Celsius per kilometer. It is declining how much? 6.5 degrees Celsius per kilometer. It is declining how much? 4 degrees Celsius per kilometer. So that's why your dry adiabatic lapse rate is greater than what? Greater than normal lapse rate is greater than wet adiabatic lapse rate. Fine. So this is all about concept of lapse rate. So question might come, what is zero lapse rate? What is positive lapse rate? What is negative lapse rate? So what is negative lapse rate?
Height increases,
Huh.
temperature also increases.
Yeah, if height increases, temperature also will increase. It is going to be called as what? It is going to be called as a negative lapse rate. If height increases and temperature decreases, it is going to be called as a positive lapse rate. If height increases and temperature do not change, then it is going to be called as a lapse rate. Fine. Now we are shifting to the concept of pressure bed. So now we are coming to the next concept, which is called as a pressure bed. Fine. Now what is pressure? Just now we discussed pressure is defined as what? Force per unit area. This is a definition for what? This is a definition you study of pressure in a physics. So how much force you are applying in a unit area, that is called as what? That is called as a pressure. Fine. Clear? For example, if I try to what? If I try to use this and try to try to put it in my my shirts, what will happen? What will happen? It is not going to what? It is not going to go on the other side. Okay, I'm trying to put this particular thing on my shirt. What is happening? It is not going to come on the other side. But if I'm putting a needle, what will happen? The needle will come out from the other side. Why it is happening? Why this is happening? Because area of this is what? Area of this is more. When area of this is more, what will happen? When area is more, what will happen? Pressure is going to be what? Pressure is going to be less. Needle has a very small area. Okay, very pinpointed, very sharp. So needle has a very small area. When it has a very small area, what will happen? it will apply more pressure. More pressure means what will happen? It will go on to the other side also. That is okay there. Clear? So this is what we define the pressure. Pressure is nothing but okay, force, how much force you are applying in a unit area. That is okay there. That will determine your pressure. Fine. Now, how do you define the term force? What is force? In physics, you have studied the term force. Force is called as what? How do you define the force? Force is referred as mass into acceleration. Force is referred as what? What is formula for force? Force is referred as mass into acceleration. How much mass of the body and how much acceleration, that is okay there. That is called as nothing but okay, force. Force is equals to mass into acceleration. Fine. Acceleration is what? Change in velocity. At what speed you are moving, at what velocity you are moving, that is called as a acceleration. Clear? But if a body is moving like this from top to the bottom, then what will happen? If the body is moving from top to the bottom, then what will happen? Not moving like this, rather top to the bottom. If it is coming, then what will happen? Then this acceleration becomes equals to what? Acceleration becomes equals to acceleration due to gravity. This acceleration becomes equals to what? Acceleration due to gravity. So that's why force can also be equals to this formula. Force is equals to mass into g, mass into gravity, or acceleration due to gravity. Clear? So if any body is freely falling, if I leave this object, then what will happen? It will come down. It will come down with a certain acceleration. Okay, that acceleration is called as what? Acceleration due to gravity. Fine. If I'm okay, if I'm throwing this body up, what will happen? If I'm throwing this body up, what will happen? It will go up to a certain height. Then what will happen? It again starts to come down. Clear? So when it is, I'm throwing, let's say with a 10 velocity, 10 kilometer, okay, per hour. Okay, let's say this object is thrown with a 10 kilometer per hour. What will happen? As it going up, its velocity will decline to what? 0. Its velocity will decline to 0, and after that it will starts to fall down onto the earth. So when it is come down to the earth, its velocity will increase. Okay, its velocity will keep on increasing, and this is happening due to what? This is happening due to acceleration due to the gravity. So force is what? Force is nothing but mass into gravity also, and this we also referred as a weight. This is also mass into gravity is also referred as what? Weight of the person or weight of the object. Mass into gravity is also referred as what? Weight of the object or weight of the persons. Any doubt regarding this one? So let's say this is a what? This is an air. Let's say air contains what? Oxygen, nitrogen, gases are there. These gases have certain what? These gases have certain weight. Why these gases have certain weight? Because they have certain atomic mass. They are consisting of electron, proton, and neutron. So they have certain atomic mass, and they are attracted by whom? They are attracted by nothing but Earth's surface. So what is happening? They are also having a gravity. So this mass into gravity will become what? This mass into gravity will become nothing but weight. Clear? So this air has certain weight. When air is having certain weight, it will apply a pressure on whom? It will apply a pressure on certain area. Let's say this air is applying a pressure on this area, and this is called as what? This is called as a atmospheric pressure. This is called as what? This is called as a atmospheric pressure. Clear? So what is atmospheric pressure? How do you define this term atmospheric pressure? How do you define this term atmospheric pressure? So air has a weight. Air has a weight, and by virtue of its weight, it applies a pressure. It applies a pressure on unit area of Earth's surface. Unit area of Earth's surface, which is referred as air pressure. Which is referred as air pressure or atmospheric pressure. This is a definition that you have to keep in mind. which is referred as a air pressure or atmospheric pressure.
Air has a weight.
By virtue, VIRTUE, by virtue of its weight, it applies a pressure on unit area of Earth's surface, which is referred as a air pressure or atmospheric pressure. Fine. Fine. So this is that's why we are using the term air pressure or atmospheric pressure. How it is measured? So we measure it as by taking a column of air. By taking a column of air, how much this column of air is applying a pressure in a unit area. How much this column of air is applying a pressure at a unit area, and this pressure is measured where? This pressure is measured at a mean sea level. This pressure is measured as a mean sea level. Clear? So how much a column of air is applying a pressure in a unit area, measured at which level? Measured at a mean sea level. Mean sea level means what? What the term mean sea level means? This is Earth's surface. This is the sea level. So this is called as a mean sea level. This is called as a mean sea level. You are not measuring it at a mountain. You are not measuring at a plateau. You are measuring at this level, which is called as what? Which is called as a mean sea level. So how much weight of column of air? So we define it as a weight of column of air applied in a unit area, measured at which level? Mean sea level. Clear? So weight of column of air applied on a unit area, measured at which level? Mean sea level is referred as what? Is referred as atmospheric pressure. Is referred as what? Atmospheric pressure. Is referred as atmospheric pressure. Fine. So weight of what? Weight of the column of air applied at which level? Applied at a mean sea level in a unit area is called as what? It's called as a atmospheric pressure. Fine. Anybody having any doubt? How much it is? It is 1034 square per centimeter. This much pressure, pressure is called as a atmospheric pressure. 1034 square per centimeter. This pressure is called as what? This pressure is called as a atmospheric pressure. Okay, it is gram per square kilometer. Gram, 1034 gram per square centimeter. This is called as what? This is called as what? This is called as your atmospheric pressure. Clear? Any doubt regarding this particular thing? So what you have to keep in mind, what is atmospheric pressure? How do you define this term? Air has a weight. Because of its weight, it applies a pressure. Clear? When we take a column of air, and what is the weight of this column of air in a unit area, then it is going to be called as what? It is going to be called as a atmospheric pressure, and this will be measured at which level? Mean sea level. Clear? This will be measured at which level? This will be measured at a mean sea level, not at plateau, not at mountain, at the mean sea level. Fine. Now you know that air, just now we discussed, when air is going to be heated, what will happen? What will happen? It will expand. Why? Because we discussed volume is directly proportional to what? Temperature. And when air cools down, what will happen? It will contract, because volume again is directly proportional to what? Temperature. Clear? Just now we discussed air when heated will expand, air when cools down, what will happen? Contract. And this results in what? This results in different pressure. This result in what? This result in different pressure. Different pressure on Earth's surface. This is leading to what? Different pressure on Earth's surface. Fine. What is different pressure on Earth's surface means? What is different pressure on Earth's surface means? For example, we discuss equator region, more sunlight. More sunlight means air will get heated. When air will get heated, what type of pressure you are going to see on equator? What type of air, pressure you are going to see on equator? Low pressure. Why? Because when heating means what? Expansion is happening. Expansion means what? Low pressure. Fine. Polar region, what is happening in polar region? Air cools down. When air cools down, what will happen? It will contract. Contract means what? Compression will happen. So at polar region, which type of pressure you are going to see? High pressure. So that's why you see different pressure on Earth's surface. That's why you see different pressure on Earth's surface. At equator, you will see low pressure. At at polar region, you're gonna see nothing but high pressure. Fine. So just keep this phenomena in mind. Air when heated will expand. If it is expand, which type of pressure is going to create? Low pressure. Air when cools down, what will happen? Contract. Contract means which type of pressure is going to be created? High pressure is going to be created. Fine. Fine. And as we discussed, always air moves from where to where? High pressure to low pressure. Always air moves from high pressure to low pressure. So when air moves in this direction, that is horizontal direction. So when air has two motions, we say air has two motion. Air can move in horizontal direction or it can move in vertical direction. Air has two motion. It can move in a horizontal direction and it can move in a vertical direction. When air is moving from here to here in horizontal direction, that is high pressure to low pressure, from polar to equator region, when air is moving, then it is going to be called as what? It is going to be called as a wind. So air in horizontal motion is called as what? Wind. When wind is blowing, you experience no. So outside when you are there, wind is blowing, what will happen? You experience. So it is which type of air motion? It is which type of air motion? Horizontal air motions. Fine. But just now we discussed there are certain air which will rise up. Air parcel will rise up. When it is heated, what will happen? Air is going to rise up. So air also has a vertical motion, and this vertical motion is called as what? Air current. This vertical motion is called as what? Air current. So air has two motion. One is horizontal motion, another is called as a vertical motion. Horizontal motion is called as what? Wind. Vertical motion is called as a what? Air current. Fine. Now the question here is, you do experience the wind, but you do not experience much of air current. Why? Can you see, if winds are blowing, you experience that winds are blowing in this direction, from left to right or right to left, you experience that. Can you experience any wind blowing from nothing but your bottom to top? Do you experience like that? No. Why don't you experience air current then? Because air has a two motion, horizontal motion also and vertical motion also. Why don't you experience the vertical motion? Why don't you experience the vertical motion? This vertical motion is not experienced because it is balanced by the opposite force, which is gravity. Clear? So air is moving up, gravity is something that is what? Pulling down. As a result, forces are balanced. That's why you don't experience what? The vertical motion. Only you experience which type of motion? Horizontal motion, because it is not balanced by any force. So that's why air has two motion. One is called as what? Vertical motion. Another is called as a horizontal motion. Vertical motion of air is called as what? Air current. Horizontal motion of air is called as what? Wind. You do experience horizontal motion, but you do not experience the vertical motion, because vertical motion is balanced by what? The Earth's gravity. Fine. Any doubt regarding this particular part? Now, what happens here is what? What happens here is a term we are using called pressure belt. So now we are done with what is pressure, how these pressures are being created, how air is moving in two directions because of these pressure. Fine. Now what the term belt means. Belt means what? This belt means an area, region, area or a region. That is called as what? That is called as a belt. Fine. So when we are talking about a uniform pressure, when we are talking about uniform pressure over any area or a region, over any area or region, this is called as what? This is called as a pressure belt. Fine. So when we are talking about a uniform pressure over any area or region, then this whole thing is called as what? This whole thing is called as a pressure belt. Fine. Fine. So like we discussed, in equator region, what will happen? In equator region, what will happen? You have more amount of sunlight, then what will happen? Low pressure, because air will get heated, so expansion means what? Low pressure. So when we are talking about this entire equatorial region, from here to here, this entire equatorial region, it becomes which type of belt? It becomes a pressure belt. Or when we are talking about entire polar region, then it becomes a which type of belt? It is called as nothing but, okay, a polar pressure belt. Okay, so that's why you have a different pressure belt. Fine. So what is the term pressure belt means? What the term pressure belt means? Pressure belt means when there is a uniform pressure over a region or an area, then it is going to be referred as what? Pressure belt. This uniform pressure could be either high pressure, or this uniform pressure could be either low pressure. Fine. This uniform pressure could be either high pressure, or this uniform pressure could be either low pressure. Fine. So that's why there are prominently, that's why you'll find there are prominently four major type of pressure belt. Four major type of pressure belt. These are referred as equatorial, low pressure belt. You have polar high pressure belt, high pressure belt. You have subtropical low pressure belt. Sorry, subtropical high pressure belt. And you have subpolar low pressure belt. So prominently you have these four pressure belt: equatorial low pressure belt, polar high pressure belt, subtropical high pressure belt, as well as nothing but, okay, what? As well as subpolar low pressure belt. And these pressure belt diagram you'll find like this. So this is, okay, Earth in which shape? Earth in geoid shape. Fine. Fine. So you have, okay, what you have these variations, which is equatorial low pressure belt, then you have subtropical high pressure belt, then you have subpolar low pressure belt, and finally the above top is polar high pressure belt. Fine. Generally, we'll see from 10 degrees south to 10 degree north, you are going to generally experience this equatorial low pressure belt. Then you'll see from 23.5 degree to around 35 degree north, you are going to experience this subtropical high pressure belt. This is south, 35 degrees. Then around, okay, 45 degree to 66.5 degree south, you are going to experience this one. Okay. And from 80 degree north to 90 degree, you're going to experience the polar high pressure belt. Fine. So these are the four major pressure belt: equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. The same thing is repeated in what? Same thing is repeated in the southern part. You know that always wind blows from where to where? High pressure to low pressure. So you are seeing the wind is blowing from here, high pressure to low pressure, a wind will blow, and this wind is referred as what? This wind is referred as a northeast trade wind, and this wind is referred as what? Southeast trade wind. So this wind is referred as a northeast trade wind, this wind is referred as a southeast trade wind. Now these two winds are referred as a westerlies. These are referred as a westerlies. And these two winds that are there are referred as easterlies. These are referred as a easterlies. Easterlies. So because you have, okay, high pressure, low pressure, wind will always move from where to where? High pressure to low pressure. That's why you have a blowing of this wind from high pressure to low pressure, westerlies. From high pressure to low pressure, you have easterlies. This is how movement of wind are going to happen. Fine. Fine. Since these pressure belts are permanent, these pressure belts are permanent. Permanent means what? They are present throughout the year. So these pressure belts are permanent, they are present throughout the year. That's why there are four permanent winds. There are four permanent winds: northeast trade wind, southeast trade wind, westerlies, and easterlies. Westerlies and easterlies, so they are called as a permanent wind. So since these pressure belts are permanent means they are there throughout the year. When they are there throughout the year, these winds are also going to be permanent wind: northeast trade wind, southeast trade wind, westerlies and easterlies. These are also going to be our permanent wind. Permanent wind means they flow throughout the year. Fine. This is northeast trade wind, this is southeast trade wind. Fine. So you have equatorial low pressure belt, polar high pressure belt, subtropical high pressure belt, subpolar low pressure belt. Since these pressure belts are permanent, you are going to see permanent wind, northeast trade wind, southeast trade wind, westerlies as well as easterlies. Fine. Now, as we discussed, why low pressure is formed over here? Why low pressure is formed? Because we discussed equator region receive more sunlight. When more sunlight, what will happen? More heating. More heating means what? Low pressure. And why this region have a high pressure? Because of nothing but okay what? Because of nothing but okay colder region, less sunlight. So contract will happen. Contraction means high pressure is going to be formed. Fine. So that's why these two pressure belts are referred as thermally induced pressure belt. These are referred as thermally induced pressure belt. And these two pressure belts are referred as dynamically induced pressure belt. Dynamically induced pressure belt. So you have two type of pressure belt also. One is thermally induced pressure belt. Another is called as a dynamically induced pressure belt. So thermally induced pressure belt is equatorial low pressure belt and polar high pressure belt. These are thermally induced pressure belt. And then you find what? Subtropical high pressure belt and subpolar pressure belt. When you have these type of pressure belt, then it is going to be called as what? Dynamically induced pressure belt. Fine. So as we discussed, which region receives more sunlight? Equator receives more sunlight. When equator will receive more sunlight, what will happen? Heating. Heating means expansion. Expansion means what is going to form? Low pressure. Here what will happen? No heating is happening. That's why contraction, high pressure is being formed. But out of these two regions, subtropical high pressure belt and here, so which region is receiving more sunlight? Whether this region will receive more sunlight or this region will receive more sunlight? Tropical region will receive more sunlight because it is closer to the equator. Closer to equator means what? More sunlight. This region will receive more sunlight and this region will receive what? Lesser sunlight. More sunlight means what? More heating. More heating means what? Low pressure should be formed. But here what we have written? High pressure we have written. Here less heating. Less heating means what? Contraction. High pressure should form. So that's why what here we have written? Low pressure we have written. That's why these two pressure belts are dynamically induced pressure belt. They are not because of sun's heating. They are dynamically induced pressure belt. But these two are okay, thermally induced pressure belt. These are due to what? These are due to nothing but okay, sun's heating. Clear? So that's why two different kind of pressure belt you can have: dynamically induced pressure belt and thermally induced pressure belt. Dynamically induced means what? Because of different reason, not due to sun's heating. Thermally induced pressure belt means it is due to sun's heating. Fine. Any doubt regarding this particular part? So why there is a creation of thermally induced pressure belt and why there is a creation of dynamically induced pressure belt? Well, let's start with that in the tomorrow's class. Clear? So what we try to cover today is what? We try to cover today is what? The first concept that we cover is temperature distribution. What are the factors affecting temperature distribution? Then we discuss isotherm concept. Isotherms, as we discussed, is a line that is connecting places with what? Places with equal temperature. And we discuss how isotherm will vary in the northern hemisphere or in the southern hemisphere during summers and winter. After that, what we have covered? We have covered concept of heat budget, that incoming solar radiation and outgoing terrestrial radiation, that we have covered concept of heat budget. Then we discuss concept of lapse rate, that is environmental lapse rate, adiabatic lapse rate, and adiabatic lapse rate can be further divided into dry and wet adiabatic lapse rate. Fine. And the last thing that we covered is we started with the concept of pressure belt. Fine. So detail regarding pressure belt we'll take up in tomorrow's. Thank you. Thank you for today. I'll exit.
No, sir.
will